radical. So how do we solve these? There's a couple different kinds. First, we can have a variable as a radicand. And what that is we have just a variable underneath, nothing else. Okay. So let's say we have a word problem where we have two people sailing a boat and they measure what's called the hull speed at 9 nautical miles per hour. And we want to find the length of the water line. Okay. Now, we're given a formula where h is equal to 1.34 times the root of L, where L is the length and h is the hull speed. All right. So we know this is 9. Okay. We need to isolate the radical. So we divide both sides by 1.34. Okay. Which gives us 6.72 is equal to the square root of L. Now how do we clear a square root? Much in the same way multiplication and division are opposites of each other, squares and square roots are opposite of each other, so they cancel each other out. So in order to clear the square root, actually I'm just going to rewrite it up here. So in order to clear the square root, we square both sides. So the square root of L squared is just L. And 6.72 squared is 45.2 if we round it to the nearest tenth. And that would be feet. Okay, so the square root of 2.5r is equal to 65. Now this has something other than a variable in the radicand, but it's being multiplied. So it's one term, it's still a monomial, not a binomial or a trinomial. So you treat it the same. So in order to solve this, I'm going to square both sides to clear the radical. So I'm going to get 2.5r is equal to 4,225. Divide both sides by 2.5. And you get r is equal to 1,690. All right, now we can have an expression as a radicand. When that happens, it looks something like this. Actually, sorry, that should be a 5. And then plus 7 equals 12. Now I want to isolate this whole radical, okay? This 7 is not under the radical, so what I want to do is I want to subtract it from both sides. I'm treating the radical the same way I would treat a variable. So I get the square root of a plus 5 is equal to 5. My next step is going to be to square both sides. Whenever you square a radical, just the radical goes away and you're left with whatever was underneath. So that gives me a plus 5 is equal to 25. I subtract 5 from both sides and I get a equals 20. Okay, another example. Here I have a constant out front. Same basic steps though, I'm going to subtract that from both sides. So I'm left with h plus 1 and that equals 10. Going to square both sides. And I get h plus 1 is equal to 100. Subtract 1 from each side. H is equal to 99. Variables on each side. Okay, and when this happens, you could end up with answers that aren't actual answers, right? And I want to explain that first before we actually start solving this. If I'm taking the square root of something, it has to be positive, right? So what we need to know is that this cannot be a negative number. So before we do anything at all, we need to keep that in mind. So this k plus 1 can't be negative. It has to be greater than 0. Okay. Greater than or equal to 0. Okay. Now to solve this, I'm still going to do the squaring on both sides. On this side, my square just cancels my radical, so that's fairly simplistic. But over here, I end up having to FOIL. And in order to set this equal to 0, or in order to solve all this, I need to set it equal to 0. So I'm going to subtract k from both sides, and I'm going to subtract 1 from both sides, so that I end up with 0 over here and k squared minus 3k here. Which I will factor. I can factor out a k. Oops, no k there. I can factor out a k, which gives me k times k minus 3 is equal to 0. And then remember, we split that. So k equals 0. Actually, I'm going to write that up higher. So k equals 0 or k minus 3 equals 0. So I have k equals 0 or k equals 3. Now, one of these is most likely not going to work. And when that happens, we have what's called a false solution. Okay. So you have to check. You have to check your answers to find out if one or is true or both are true. So we plug it in. So first I'll plug in 0 for k, and I get the square root of 1 is equal to negative 1, so 1 is equal to negative 1. That's not true. So 0 is not a solution. So then I'll try 3, and I get 3 plus 1 is, sorry, the square root of 3 plus 1 is equal to 3 minus 1. So I get the square root of 4 is equal to 2, so 2 is equal to 2. This is true. So this is a solution. Let's try t plus 5 is equal to t plus 3. So we have the square root of t plus 5 is equal to t plus 3. So first I'm going to square both sides. And I get t plus 5 is equal to t plus 3 times t plus 3, which I will FOIL. And I will end up with t squared plus 6t plus 9. I'm going to subtract everything from this side so that it's set equal to 0. So this becomes 0, and I have t squared plus 5t plus 4. And now I need to factor this. So I have factors of 4 that will add up to 5. It's 4 and 1, right? So factors of 4 that add up to 5 are 4 and 1. So I have t plus 4 equals 0 and t plus 1 equals 0. So t equals negative 4 and t equals negative 1. And now I need to check them. So if I put negative 4 in, I get the square root of 1 is equal to negative 1, or 1 is equal to negative 1. This is not equal. So negative 4 is not my solution. I'm just going to double check the negative 1. So negative 1 plus 5 is equal to negative 1 plus 3. So that's the square root of 4 is equal to 2. 2 is equal to 2. This is good, so this is good.